Thank you, everybody, for being here. I see that there's a lot of excitement in the room about the ZNC series. Right now, we're going to be breaking down the building controls, and so you have a better understanding of how to implement that in your own ZNC process. And the ZNC series will continue to go on, so stay tuned for the ones in April and May. But before that, we're having a celebration for the transportation in the 2030 district. And that's actually going to be here in Founders itself. So make sure you come to that. Stay tuned on our newsletter. There's a lot of things going on we don't want to miss yet. And so that's going to be celebrating GVSU and Spectrum, and their recent award is a national award for being the best workplace for commuters of the year. So we really want to jumpstart the conversation how to make transportation in Grand Rapids a better place to be. So we have that coming up right here in Founders, but April 18th, you really don't want to miss it. It's going to be the Energy Summit, and it keeps getting bigger every year. We have an NFL keynote, Will Allen, who's going to be speaking, and also we have a signed NFL helmet that's coming through and different prizes. So it's a really great event. Actually looking around the room, a lot of you are already coming, so that's really great to know. And if you still need to get your tickets, grab them now. It's coming up sooner than you think. And but you're not here to listen to me after all, right? You're here to listen to the experts. So we have the moderator, Russ, from Hurst Mechanical. Hurst Mechanical and Bergman Associates are the newest members of the 2030 district, so thank you so much. And if you're interested in being in the 2030 district also, please reach out, because there's a lot of awesome benefits that come with it. And we have Rob from the Berner Company, and we have Greg from Trane, and Mike from Foresight. So I'm just going to have this.
Who are you?
Oh my gosh. I'm Jillian. I'm the programs manager with the USGBC. But most people know us through our programs of the Battle of the Buildings, which, by the way, registration is up until the end of the month, so make sure you get your buildings in. And also the 2030 district, which we're here today about. And so this is going to be a very conversational situation, so don't be shy. No question is silly. And, well, you're going to take it away. And, well, thank you everybody for coming here.
Thank you, Jillian. All right, here we go. Again, welcome. Welcome, everybody. We're going to have a great time together for the next 45 minutes or so. Again, let's make this light, and if anybody has a question, feel free to ask it at any point, definitely. We don't want this to be an intimidating subject. In fact, I bet you every one of us here has feels right at home with this subject. We're calling it something a little bit different. It's a lot of what we've been doing in the past. It's a lot of energy optimization, reducing our EUIs, that kind of stuff. So we're here to discuss it today. I have a great set of panel experts next to me that will be passing this mic back and forth. First, I'd like to get started by just introducing each and every one of us here, and I'm going to start off first. So my name is Russ Borst from Hurst Mechanical. We're a mechanical service contractor in West Michigan, and we specialize in design, build, construction, service, and controls. Also, we dabble in the energy side of the spectrum as well. So I'm your moderator today, and I'm going to pass it over up.
Hi, my name is Rob Berner with Berner Company. We are a high-performance building solution project management organization, and we also are kind of on the cutting edge of IoT, wireless sensory networks, and their applications within the built environment.
Greg Bleeker with Trane. Many of you probably know of Trane as an equipment company. Been doing controls as well here there locally for probably 30 or more years. And over that time, we've developed a lot of systems expertise that we've been using to help customers save a lot of energy in their buildings.
Mike Troupos with Foresight Management. I am an energy engineer, so we help our customers save energy and money in two ways: by reducing usage in the facility, and then also by reducing costs on on utility bills. So you can think of us as outsourced energy managers and interface with a number of different facilities.
Again, if you have questions during this, I'm going to start out with a couple questions for the panelists to get us rolling and hopefully get the juices going here. So, panelists, how do building controls fit into the ZNE approach? Anything you guys could share there?
Sure, so one of the key overall approaches to the ZNE, or the zero net energy approach, is before you start adding renewables or things like that, is to get the overall usage down in your building. So efficiency first, then you supplement with renewables to get yourself to a net zero. Controls ends up being one of the major pieces of the building efficiency picture. You can do lighting, we were talking about that a little before we got started here. Controls is huge for getting the usage down in your building, and that makes it almost critical, almost even a prerequisite before you're going to go do net zero energy.
So I really want to echo Greg's point. I probably say this too much, but this is the easiest way to say it. The best efficiency is off. It's really simple. If you're not running something, it's not using energy. And exactly like you talked about, having a robust control system, make sure things aren't running when they don't need to be.
My only point that I would add to that is in doing energy audits, one of our greatest ECMs has been in the control side, and I echo the off. Have a quick story. We were doing an audit of a facility, and the whole building was all lit up at night. It was, and as the night went on, I noticed the lights would go off. We had meters in there, and that was how the cleaning people actually knew when they were done with their certain areas, is by turning off the lights. But how much energy was that costing? So yes. Next question. You know, where do we start? You know, where does you know, your office manager or your industrial plant manager, where do they start? Where's a good place to start harnessing building controls for a facility?
I would say the easiest way is to look at your controls. So everyone has controls in their building. It can be as simple as a thermostat, a dummy thermostat that's just set to a temperature all the time that you can change. You can have programmable thermostats or entire building automation systems. But regardless of what you have something that's controlling your building. You have to look at it. I can give you a great story of an industrial facility I was in. They had programmable thermostats, and it was a wide open floor. They had heating and cooling rooftop units. So I walk up to the first programmable thermostat, set to cool, it's in the summertime. Walk down to a couple more, they're all set to cool, it's cooling off the building. I go over to the corner and look at it, and again, there's no wall or any divider. And this other unit is set to heat. It's blasting heat and probably 2 pillars down. The other one is blasting air conditioning. How does this happen? People get cold, so you have to stay on top of your controls. Definitely the lowest hanging fruit is checking. And if you have a building automation system, you can do a lot more than just spot checking. You can make sure that your schedules and your set points are set to the appropriate levels. We see this a ton as well, where you have some parts of your building set to heating at 70 degrees and others heating at 75. Well, the units that are set to heat at 75 are going to run a lot more than the units that are set to heat at 70. So what you have is your units getting run a lot more that are set to the higher temperatures, and the ones that aren't running a lot less, so you're going to have a lot less equipment lifetime. You're also going to have a lot more energy consumption. So a lot of it, I would say, the easiest thing to do is just sit down and look at your building control system. What's going on? It doesn't take an engineer or any professional to say, when are we in this building, and should it be running when we're in it? Absolutely. And should it be running when we're not in it? Certainly not.
Follow that up. Do I have to do the whole building right from the start? You know, can I just do one unit? Any comments on that?
No, it can be graduated over time. But I think it's important in this day and age for us to not take a symptomatic approach to building automation. We try to put out too many fires as owners of buildings, and I think it's very important for us to look at the whole building It's going to, I know what, with Foresight, their ability to look at the energy bills and Trane can do a holistic picture. I mean, the idea is that, you want to know what the philosophy of that building is going to be, right? What its operational use is. So it's always important to, if you've had a building that hasn't done retro commissioning for a while, it's important to kind of get grounded into looking at all of your energy infrastructure. So that's, I would say that, yeah, you can graduate it, but if you don't have a master plan, then you could be losing a lot of pickup, a lot of opportunity. So, and I know a lot of the words that we're going to be talking about is like low-hanging fruit. Some of that low-hanging fruit is already done. There's a lot of people that have done it. But we've taken LEED certified buildings, even here in Grand Rapids, and because we use this philosophy of a holistic approach, just using, not even doing a wholesale retrofit of air handling units and chillers and boilers and all this sort of stuff, but just through controls, we were actually to take a building that had a 95.95 kBTU down to right now the spot check on that is less than 25, which according to the Net Zero program, the ZNC program, that's what you need to be at. So there's some really cool things you can do with controls. We'll talk more about that, but yeah, you can certainly do it graduated.
Yeah, so just one other thought there. When I think of controls, I think of controls with two kind of main functions that both apply here. The first is it gives you the ability to see what's going on in your building. Like Mike said, you got to look at them. When is stuff running? What is it running to? It's information that it provides you. We'll probably talk about some metering. You get a lot of good data out of your control system, both on utilities and the operational point. So it's information coming at you that you can use. The second piece of that is it gives you the handles, the levers to make a change in your building. You can turn around and use those same controls, that same control system to have an impact, to optimize what you're doing, and hopefully reduce, improve the overall operation of your building, both efficiency and comfort, productivity, things like that. So two kind of main thoughts there on controls. It tells you things, and you can use it to do things.
Very good. This is the point where if you guys have anything. Yes, Sherry, please.
So Mike mentioned how your controls are affected, and it brought up my thoughts on space heaters. Does someone want to talk about how space heaters can affect your control system?
I definitely can, but let's let these guys.
Go ahead.
All right, space heaters. I very near and dear to my heart. We've had it a few different times when I've done energy audits where walking around with the facility manager and he goes, yeah, this area right here, this area, we're having all kinds of troubles with it. And I'm thinking, this area, you have a VAV system, you have in-floor heat, and you got people with space heaters under their desks. And I'm going, why? What's going on? Well, we broke it down. We figured out that the space heaters were affecting the thermostats. So they were putting the VAV system to full cool. And also they were running the in-floor heat at 100%, just because their space heater was doing. So little education for office people, and so that's part of my job, is to educate them. It's not just the cost of that little space heater that's costing you money. It's also cooling your facility down, and it's trying to heat it back up. So space heaters are near and dear and need to go, definitely. There's a solution to the problem if there's a problem if that person's cold. So anybody else?
So, this topic is about harnessing controls. So controls is not the panacea that some people say, well, based on spec, we've got a control system. Now, Trane makes a hell of a control system. So does Honeywell, so does Johnson. Niagara's got some good stuff, right? I mean, so it depends on what you go proprietary or non-proprietary. I think at the end of the day, it's what your management strategy of that is. What are you harnessing? So when you have these rogue outliers like space heaters and fans and other things that are augmenting comfort, this becomes a cultural thing for your organization that you have to discuss. And now there's technologies that we can actually pinpoint, can everybody hear me? We can actually pinpoint based on comfort levels where people are, right? We can do spot metering. There's good prep packages that we've implemented called Building Advice. There are now apps that those brainiacs in Silicon Valley are creating, like Comfy. These are all this is what Berner Company. We're answering the questions about trying to figure out, comfort is important, and decreasing these rogue outliers that are energy hogs are also equally important. So what type of culture are we trying to create? And those are some things that you have to look at. But Comfy's a really good app for that is just starting with this, that relays information into the automation system for real-time spot checks for comfort.
One other thought on space heaters. Don't just look for space heaters. Coffee pots under thermostats, blanket warmers in healthcare, copy machines in office spaces, right? All of those close to a thermostat can create exactly the kind of problems that Russ is talking about here. Rob, you mentioned at one point earlier wireless controls. Wireless is a kind of a good answer to some of that. If you've got a wireless sensor, it's a lot easier to move it than trying to move the coffee machine or the copy machine or things like that. So a lot of options there, but a lot of things to look for.
Another question. I'm gonna take us sideways just a little bit here. The technology is there to do almost anything you want, and it includes things like Rob mentioned about Comfy, so you can actually, imagine everyone's cell phone has a temperature sensor, and they can communicate what your nominal comfort is throughout a building, and even if you're walking around. So there's all kinds of technology. But I don't think the problem, and there's going to be a question at the end of this, I don't think the problem is technology. Or maybe it is, because really what we're trying to do is help people become comfortable or get their job done well. And that includes ventilation as well as comfort. And but the principal criteria for success in most buildings is what I call acoustic tuning. I don't hear any complaints. Well, no complaints means nothing as far as your energy use. It just means it's cool enough or it's warm enough. The chiller system is oversized anyway, so it's going to be cool enough. The heating system is similarly oversized, so it's going to be warm enough, even if they're fighting each other. So I think the bigger challenge is to how do we, and then by the way, who signs up for building ownership or building operation with a degree in engineering? Who knows as much as any of these guys on the panel? Nobody does. And they're busy doing their day job. So the challenge is, how the heck can you do your day job and run your building well? And so I guess that's the question I pose to you both.
So you're hitting on a key piece there, right? A control system doesn't operate in isolation, right? It's got people running the control system. It's got people in the space that are providing feedback, maybe acoustically in the form of complaints, like Jim said. But there's people here that are on both ends of this thing. So engineers, consulting engineers in the room, and in the industry do a pretty good job nowadays in putting in high performance systems. In a lot of cases, they're putting in some pretty cool stuff when it comes to energy efficiency, sustainability, things like that. But with that comes a level of complexity, and the demands on the operators and the maintenance staff are pretty intense in a lot of cases. And if they don't have a degree in engineering, which certainly isn't required, but the systems nowadays are tough. And there's a lot of opportunity to save energy, but there's a lot of opportunity to go wrong. Rob, you talked about LEED buildings. You can save a lot of money in a complicated LEED building if it's not being operated the way it was originally conceived or intended to. So owner training is key. Operations staff being comfortable with the system they have and the provider that you're using. Not managing by complaint, not prioritizing complaints. If you're a maintenance guy, you've got somebody complaining, the direction they get is take care of the people. They're not prioritized or incentivized based on utility bills or reductions in carbon footprint or anything like that. Their job, their reviews is all based on how well am I taking care of the people that live and work in this building. And as a result, it can create exactly the problems that Jim mentioned. And it's tough, but you got to work with the people side of it as well.
Yeah, Jim, you bring up a really tough point. We see this all the time. I mean, people are stretched and people are very busy and don't necessarily have the time to focus on this. I will say, from my perspective, the facilities that I have been in that seem to do a lot better when it comes to managing these things, there's a culture there. There's a culture of due diligence. There's a culture of saying, we're not just going to put out fires and we're not going to optimize for convenience. We see that all the time. People will come in and install something, and you can't blame them from their perspective. Of course they're going to optimize for performance. They don't want to get the call back that it's not working or that they're unhappy. But a lot of times we'll come in and say, yeah, this has been optimized for maybe reliability or ease or comfort. You can optimize it for those things, but also optimize it for energy. It might take a little bit more intentionality. It might take a little bit more discipline, but you have to do it. The other thing, Jim, that's tough is it takes time. As much as these systems can be very sophisticated, you can do a lot of cool things with them. At some point, you have to empower somebody in your organization to have the time in the spring to review your controls and in the fall to review them as you go into heating and cooling season. You also have to be doing things like making sure that your equipment is being checked. So having preventative maintenance contracts. I know that's a little bit off in the weeds, but having that intentionality. So I think for me, I find there's organizations that act very reactively when it comes to their facilities and how it's operating and the energy it's consuming, and there's others that are proactive. I don't have an answer on what you need to do to make sure that your facility is the proactive facility, not the reactive one, but there definitely is that piece of like a culture in your organization.
Questions?
So this may be really fundamental, but so I own a couple buildings, and what I'm hearing you guys say is that when we lock the door at 6 o'clock and we're done for the night, my HVAC system should be off. So that I would love to have clarification on that.
Very good.
Well, so it's all dependent upon your operations,
Right.
and if everybody in unoccupied, if the strategy there is that this building needs to go into unoccupied, then it needs to be set back. So, we would look at exactly, or any of these three, and any of the other individuals here that are vendors in the space would look at, what are your goals as a building owner, right? What are you doing right now? It's just not, there's not one silver bullet.
Okay.
But from the idea of if I'm leaving for the day, does my building need to go into setback? Does it need to go into an unoccupied schedule? Yes.
Okay, so I did that, but that's not off. That's different.
That's
from
correct.
off. Okay.
No,
Okay.
no. You are demanding and consuming a lot less at that point.
Yeah, so the difference between unoccupied and off, I think, is a key point, right? In a lot of cases, there are things that can be off. If it's a toilet room exhaust fan, right? There's no need to ventilate that bathroom when nobody's around, right? That can be off. The unoccupied mode for that equipment is off. If it's ventilation, right? There's not people in the building. We don't need to bring in a whole bunch of fresh air to keep the air quality where we want if there's no people there and there's nothing else in the space. So the ventilation can be off, just flat off. There are some things that can't be off, like the temperature. We can't have it totally off because it'll get to 0 degrees or you'll freeze pipes or bad things will happen, right? So we want it to be off, but it can come on if it needs to if it gets too cold. And hence the setback. So we set the temperature back or up in the summertime. And as Rob pointed out, it really depends on what you're doing in the space. How warm can it get when nobody's there? How cold can it get when nobody's there? Can I shut off the ventilation? Can I shut off other pieces of equipment? Can the lighting all go off? Or you need a little bit on for security? So that's kind of the key question. How off can we get? And as Mike mentioned, the more off, the more savings.
Yeah.
Yeah, it's not just an optimal start. There's also optimal stops. And one of the things, if I could just add on, is that it also depends on what your startup looks like. So if your individuals in a, you know, in a July day, we have a design day, and your individuals are demanding, you know, at 70 degrees, and we put a setback on there, then we need to look at how fast that space is going to pressurize so we can actually get right to the temperature. So, you know, because again, that's part of culture. And if you are a person that owns property where you have tenants, then that's money for you too. Because again, as our ad hoc panelist over here had said, that it is an idea. We're really at the bottom line is what type of feedback we're getting from our customer. So and you know and that doesn't mean that, you know, we're talking about tenants. We're also talking about employees and, you know, and how they're using the space too. So yeah.
Do you guys have any magic numbers? Like, how long would it take it? How far back to set it?
So the question is how much of a setback do we have, correct?
To get optimal energy efficient, but still be able to be returned where you need it to be.
I guess the short answer is a lot of it does depend. I find for most facilities, if you're just a standard industrial facility or commercial facility that doesn't have temperamental product or temperamental things that need to be kept at in a relatively tight threshold, set it back to somewhere in the high 50s, low 60s, maybe 65, depending on your tolerance when you're unoccupied in the winter time for heating. When you're unoccupied in the summer, a lot of it, like you guys mentioned, is like your thermal load. If you have a huge building, it's full of a concrete floor, it's going to take a long time to cool it back down. You maybe don't want it to swing much over 78 or 80. If it's just a small building and it can quickly jump back, maybe the low 80s. A lot of it is your tolerance too. If you really want to milk it higher or lower, you can absolutely do that. The other thing we talk about is just being mindful of when you need to fire your units on to be in the building. So obviously, if everyone shows up at 8, you don't want your heating system to turn on at 8. You got to figure out when it'll do that. And like we talk about the smartness of it, things. I have one of those Eco-B4s. Consumers Energy came out and put it on for me. Thank you very much. And that thing is sweet. You set a temperature and what time you want it, and it actually has algorithms that know how far backwards it needs to go to heat my house up so that it's at the temperature I want when I want it to be there. One more thing I want to mention, just off of Rob's point, which is good, on like your thermal loads and kicking things on, especially in the summertime. There's another nuance, and that is on your utility bills. A lot of customers with larger facilities have demand charges, so that's how much energy are you drawing at once. If you fire on all your equipment at once, that can skyrocket your demand charges and ultimately incur a lot more cost to your facility. So we find, especially with big industrials, they'll fire on processes over a course of a couple hours, as opposed to turning everything on at once, getting this huge inrush, and then having to pay those charges. Does that answer your question a little bit?
Yeah, thank you.
Key point here, just real quickly. With technology, now you can bifurcate which are demanding more load, which units are demanding more load, and which aren't. That's a key point, because in our day, and you as a facility manager's day, you have probably a whole bunch of time devoting to your building, right? You're putting out fires, you've got other things, and you're also doing whatever normal things you do to keep the day going. Well, one of the things that we've discovered is that if there's a way in which you can actually start separating your demand loads, so in this case, let me give you an example. We can easily, based on platforms we're putting in, that we can actually easily put exactly what is the demand for each unit and what is the biggest energy hog on any given time. We can see that real time also with report cards from anything from chillers to air handling units to terminal units and so on and so forth in real time, so that as a facility manager, you can actually begin your day with your cup of coffee, pull up a report card, and know where 80% of your time is going to be dedicated versus just fixing the alarms. The point is that you want to move from being, as all these gentlemen have said, going from reactive to proactive. So it's important that you look at it's not just getting the data, it's actually then understanding, what's the abstract. We call it data abstract, but what's the data abstract? What is it telling me? And how is it telling me? So a lot of this technology that's out there can help you do that as a facility manager, right? But it boils down to, I think, key things. There's management strategy, and the second thing is, Mike had said, right, was that you need to be looking at schedules both for winter and for summer. I mean, that's a key. And we see this all the time, don't we? We see it all the time. You know, where you get onboarded with your commissioning and you got one schedule, and we'll immediately see a major pickup in energy conservation with that.
Thank you, very good.
Actually, Rob, can I echo on that?
So I have a great story to echo what Rob was just talking about there, and that is Holland Public Schools. We do a bunch of work with them, and they had contracted us to look at their building automation systems. So they get them installed to spec, and they set them to just regular set points, and they said, what's going on in our facility? Can you guys take a look? So we dig into the building automation system, and we find exactly what Rob's talking about. They don't really have summer versus winter set points. They don't even have setbacks in the summertime when things are going on. And this is not a fault to Holland Public Schools, like they didn't have their act together. Their facility people are spread very thin there. So we went in and now on a biannual basis, so when school is done and when school begins, we go through, we meet with their facility director as well as some people on staffing and operations, figure out what buildings are running, what buildings aren't, what spaces are going to be occupied, and then we set it all according to that. And then we can set things to be unoccupied when they don't need to be there. We can set the temperatures all standard across the entire facility. So we've been doing this for a couple of years now and tracking it. They have not done any major other improvements, and they've seen a 5% energy reduction in their facilities across the board. Which, when you think about it, across a district, that's a lot of money. And Holland Public, just like all the other school districts, they want as much of the resources to go towards educating children as possible. So it's really exciting to be able to see them have more resources to allocate towards their core goals as opposed to spending it on utility bills. And I will just close, Sherry's going to love me for this. Holland Public Schools High School won Battle of the Buildings last year, and a lot of that was because they have been optimizing their controls. So this stuff does actually work. It's not just words that we're saying. It's actually like cool things that we can see and actually measure the results associated.
Yeah, I work in energy efficiency, and one of the things I like, I don't see it often enough, is demand control ventilation. You know, doing a RCX project using CO2 sensors. And some of my colleagues talk about O2 sensors. I really don't know what the difference is. Maybe a dumb question, but
Not a dumb question.
why would you say I like O2, I don't like CO2?
Very good. We can definitely have comments on that.
I'll give it a shot. That may be a little deep, but we'll give it a try. So CO2 is certainly a lot more common as a sensor rather than O2. And ultimately what you're after is you're trying to bring in an adequate amount of ventilation for the people that are in the space. And it kind of goes back to the philosophy of the sensor. You know, the thinking, I'm going to speculate here, behind an O2 sensor is let's make sure we have enough oxygen for the people to breathe, to make sure they're good, I guess. They're not likely to keel over, I suppose, but maybe once. So that might be the thinking there, but on the CO2 side, if you go back and look at it, it's not like CO2 is a component, like an indoor pollutant. When we hear about greenhouse gases and so on, it's not like CO2 is a pollutant that we're trying to get rid of. Inherently, the CO2 sensor is an indicator of how many people are there. So it's a matter of when you have a certain number of people and they're doing a certain level of activity, they will produce a given amount of CO2 through respiration, breathing, and so on. If we measure that level of CO2, we can calculate or approximate how many people are in the room. That is a signal to the automation system to say this is how much ventilation we should bring in. So if you're going to do demand control ventilation, and strongly recommend it, there's certainly ventilation is a huge component of energy usage in a building. You want to be careful that you know what's the design occupancy in the space, how many people, what are they expected to be doing. An office area is very different from a gymnasium where people are playing basketball or something like that. And then use that CO2 as an indicator to say this is how many people are in the space at this given time, this is how much ventilation air I should be bringing in. The other caveat that I'd add to that is if there are pressurization requirements in the space, so exhaust fans or processes going on, you don't want to cut your ventilation down so far that you're sucking air in at all the doors and every leak and crack in the building. You'll cause a lot more problems there than you've solved and probably driving your energy bills as well. So I don't know if that answers the question. That's just my perspective maybe on demand control ventilation.
No, that's fine. I just, I haven't had a lot of experience with O2, and I don't know if I'm hearing something that's off the wall. All I've ever heard of CO2 sensors and doing it that way.
Yeah.
Based on, you bring in more air when the CO2 gets to a point where it's maybe unhealthy or not the best environment to be in, you start bringing fresh air. I'm happy with that point.
Well,
Unless-
so I'm of the mind that more sensors the better. I say that a bit tongue-in-cheek because we're kind of in that space. But again, it doesn't really mean anything unless you can actually make meaningful data out of it. So an O2 sensor is just going to give you a particular data point that you didn't have before as a facility manager. But what also is interesting is integrating your system with knowing how many people are actually in the occupied space. So if you're using a BLE wireless sensory network that you've got all your employees on BLE or your visitors or whatever, and this is where our world is going to, is that when they're entering the building, they have a badge, and that badge is accessing doors, and that door is also, that particular badge is also chirping that it's being read. So, we're kind of answering the questions of how does that integration work with looking at the sensors that Trane is creating within their energy infrastructure, and then look at how we're actually bringing the algorithm to how many people we actually have in that space, what we know from a legacy standpoint, what the spot metering is looking like. I mean, these are all the things, this amalgamation is a very cool thing that's happening, and you guys are gonna, be the, we're gonna all be able to benefit from it. So, so I would always say embrace another data point, and we'll figure out a way to create a better user experience for it, so.
Thank you. Great questions. Let's keep them coming.
I had a question about pneumatic controls. I was at a building last week which was at LEED Gold. It was an addition to a building we had recently achieved LEED Gold. And I was surprised when I went to the mechanical room, there was all pneumatic controls. And what I was wondering is how does that work as far as compatibility with the new control systems? And also considering, I kind of thought pneumatic was on its way out. Should people think of doing that if the coming labor force is going to be more geared toward digital controls?
No, very good.
We'll let the Trane guy speak to this.
Thanks, Rob. I appreciate that. So, a number of very good points there, right? So, and I'll start with the last one. The labor force change is significant that we're going through in the industry here right now. There are fewer and fewer people that are able to even work on or deal with pneumatic controls. They can function acceptably if properly maintained, and that's a big if. But even with that, there's a lot of downsides that you get with pneumatics or there's a lot of, let me say, upsides for digital controls that you don't get with the pneumatics. To Rob's point here earlier, getting the data is a very key piece of making buildings as efficient as possible. With a pneumatic system, you get no data. You can't save a trend on a hard drive. You can't get high resolution, utility data or building temperature data or number of people in the space or something like that. Pneumatics is purely a temperature control device. That being said, we do see some attempts to kind of integrate the two. Somebody can't, bite the bullet and replace a whole pneumatic system all at once. We see some attempts to kind of do some day-night with pneumatics. Again, it's a lot of work. It's got to be maintained. There's not very many people that can do it. And if you can get digital by any means possible, by all means do so. If only to have people that can work on it, to get the data out of it, to get some more precision, some accuracy. You're not calibrating pneumatic thermostats like you used to be. There's just so many reasons. You make a good point. A LEED building with pneumatic thermostats is probably not living up to its full potential. Probably is almost certainly not living up to its full potential.
I definitely agree with everything you said, Greg. The other thing I would add is the utility companies really like to see people update their pneumatic controls. So what we're seeing is Consumers Energy. I think Mr. Namus is here from Consumers. If you have questions on that, but basically they offer incentives. If you take your building from pneumatic controls, which have all the drawbacks that were just mentioned, to a digital system, they'll give you an incentive for implementing that work. So not only is there quite a bit of capital outlay, but there is some opportunity to recover that cost. But again, the utilities even see that this is a beneficial change that results in significant savings.
Just to follow it up on my end, I have 52 service technicians that travel West Michigan, and I bet you I have 3 or 4 out of those 52 that are pneumatic specialists, and so you can kind of see the percentage. And there isn't too many from Ferris State University where we hire most of them learning the pneumatic side of it. Still, there's hybrid systems. Anytime in the industrial facet where we have to use the muscle of the pneumatic muscle, we still will do that in some of the actuation and partner that with our temperature controls. So that's where, but to his point, 99% of it should just go all DVC.
I think just as equally important is if you have legacy issues, not just with pneumatics, but also with old DDC controls. So if you've got an old Novar system, I mean, there's a point in time where, especially with our skilled trade environment that we have, and you don't have, there's a lot of issues right now, I think, plaguing our industry in the skilled trade environment. But one of the things that we definitely know is that the acclimation of people getting into legacy versus just keeping up with technology. When you have old controls, we've seen, a particular case study that we've had in Essexville, isn't that right? Essexville, where we, just because they had an old Novar system, we were able to upgrade them, and it was a payback of 18 months. So, I tell you, any type of building, we love funding those types of projects because they are a fast payback. So we love providing those financial packages for that.
Great question. Any others? All right, I got one for the panel. All right. Couple things. One, how do I pay for my control system? Is there anybody out there that can help with paying of the control systems? Is there a payback for control systems? Let's go there first.
It's a great question, Russ. We get that quite a bit. Like I mentioned first, you can get some of your control systems likely paid for if they're extremely out of date through the utility programs and their incentives. The other route you can go is a program called Michigan Saves. And how Michigan Saves work is they offer financing for energy efficiency projects. So if you say, I really want to do this, I see that there's an ROI here, our facility is not functioning how it needs to function, and we have okay credit, you can contact Michigan Saves and work with them, and there's a pretty high likelihood you can get your project, get a loan for your project to be able to implement it. On the ROI side, that's a little bit tougher of a question. Like Rob mentioned, you can get as low as 18 months if you have a really bad system that's not functioning well. Probably realistically, we see, somewhere in the 5-year ROI range. But again, the hugest caveat on all this is if you buy a control system and then don't sequence it correctly, if you don't commission it right, you're not going to see any savings. So a lot of it is implementing it, but then also making sure that when you implement it, you're commissioning it correctly and making sure that it's operating correctly. But that's kind of the avenues you can go for financing and some of the broad ROI strokes. Maybe you can correct me if I'm wrong.
No, I think you're spot on there, Mike. Certainly the ROI depends on what you've got in terms of an existing system. Is it from a provider that's got a pretty good history of backwards compatibility that may be able to pull in some of the older legacy systems up to a new standard without doing a wholesale gut and start over? But a lot of variables there. I do like the Michigan Saves program as well, along with the utility rebates, and there's an interesting kind of twist there. John maybe can speak more to it, but if you have the rebates and the Michigan Saves, you can qualify for some reduced rate financing on consumers and DTE, make the rate on the loan quite attractive, and it turns into a pretty good package for people. Anything to add there, John? Is that
0%, 30 cents plus,
Yep.
$100,000.
Yep, with sufficient amount of rebates, you can get it all the way brought down to zero, which is pretty incredible.
And Also, for those that are in Grand Rapids still, correct? Sherry, we haven't extended this out to other places outside of Grand Rapids, but there's also PACE financing that you might want to consider if you're if you own a facility here in Grand Rapids. So.
Very good. I've heard lots of comments today about preventive maintenance, tune-ups, optimizing ventilation, demand control ventilation. How important is it to optimize your system, and how often do we need to do preventive maintenance? How often do we need to do a tune-up? Consumers Energy, I just found out, John mentioned it, their smart building controls tune-up. They're going to be doing a prescriptive measure on that. And boy, that was just music to my heart there, because we do a lot of preventive maintenance, and that'll go along nicely with it to give you guys some money back from doing that. But I'd like to hear it from these folks. How important is preventive maintenance, optimization?
I'll give that a shot. It's critical to be sure, right? As Mike said, in a school district where you've got seasonal changes, you've got schedules, summer, winter, making those adjustments is absolutely critical. You've got a building or a facility where the usage has changed or the schedule has changed. Being as proactive as you can with getting those adjustments made is key. There are a couple different approaches, and I'm not sure that one is better than the other necessarily. Some folks like to take a more periodic approach to preventative maintenance, where they get on a regular schedule that says every X number of months, every X number of years, we go through and we do a wholesale recommissioning or retro commissioning of our facility. There are also ways to do it on a more continuous basis, where you try and leverage some of the automation built into the control system, plus the human side of looking at your needs and so on a more, I'll call it continuous commissioning for lack of a better term. But in either case, it's absolutely critical that you pay attention to what you have and make sure you stay up with it.
I can go a second. My colleague Brian is in the back, and he's probably rolling my eyes because I love using this one in a meeting when we talk about preventative maintenance. I always say, you can buy a brand new car and probably drive it 40,000 miles before the engine blows up, or you can get your oil changed on a semi-regular basis, and you can probably get 200,000 miles out of your car. The same concept works for mechanical equipment. Like everything, there's parts that are moving. Those parts that are moving can break. So we find our customers vary from anywhere from maybe 3 months to a year having a technician come out. It's checking belts and filters. It's very simple stuff like that to start. And then you get into more deep stuff, especially when it comes to your heating systems, where you can make sure that your burners are what's called tuned up, and making sure that the air and the fuel are mixing at appropriate levels to get the maximum amount of combustion. Like we've been talking about, there are incentives for some of these things, especially the tune-ups, and we find that a lot of it does vary based on your facility, but a lot of places do the spring and fall tune-ups. So you want to make sure that all your air conditioning units have been looked at before you start the cooling season. That is especially nice when your units are old or have issues, so you don't have it in the middle of July on the hottest day and it fails, and then your office is boiling. And then again in the fall, looking at all of your heating equipment and making sure that it's functioning. Again, equipment that is maybe more temperamental would potentially need to get looked at more frequently. If you have newer, better functioning equipment, maybe less frequently. But there's absolutely value in making sure that your equipment is running, not only from a longevity standpoint, but also from an efficiency standpoint.
And that's something that Consumers Energy will incentivize once every other year. And so most of you who have boilers will be doing the CSD one because it's regulation. So those guys are going to be in there anyway. Why not go the extra mile and make sure that machine lasts for 20 extra years and do full tune-up?
And that's Josh with Consumers Energy.
Yeah.
He's an energy advisor. So his territory is what, North 28th Street all the way to TC?
Yep.
All right, cool. So I'm going to take it a little bit further, which is, do you really know what your machine is telling you? Do you really know the last time when Hurst or any other service provider, and Hurst is a hell of a company. Well, Sherry paid me actually, but I don't know where it may have came from you. It's amazing how money is floating in this world. But, you know, do you really know the records of the stuff that you have? So we've been talking about data points. And one of the things that we find out is preventative maintenance may not need to be on, you know, every piece of equipment, you know, every quarter. But do you know that? Do you know exactly what points need to be fixed? I mean, as they said, and I think it was Greg, but in the mechanical world, things slip. So do you actually know a report card on that unit right now that is telling you that this is actually slipping? I mean, we're in a world where that, you know, we can actually hear sounds within equipment to know if it's slipping. I mean, it's pretty cool what we're about to begin to do. So I would say it's when you're looking at preventative maintenance schedules, as a facility manager, when your technicians, if you don't have a better way to doing this, but if your technicians have spent the time of doing site reports and looking at each equipment, I know this stinks, okay, we're figuring out a better way of doing this, but that is data for you to know, am I supposed to put this on a more frequent PM schedule? Or if you have a vendor partnership that's not telling you these things. I mean, I have been in many situations where I see more vendors leveraging customers than the customer leveraging the vendor. So yes, tweaking and tune-ups are really good, but so are fresh eyes, and so are the eyes that have seen your equipment. So that's pretty much about everything I had to say on preventative maintenance, but it is important to have it.
Rob, just one quick thing here. Rob just mentioned something that perked my interest. Is now we're talking about harnessing building controls, but we're actually narrowing it down to right to the equipment itself. So if we have a rooftop unit, we're trying to optimize the equipment controls on it. So if our demand control ventilation says we can shut down our outside air, we're doing that. We're slowing down the exhaust fan at the same time. Air conditioning wise, if we're running a compressor, we're only running one condenser fan motor, and we may have it on a drive, and we'll bring it up and down together to optimize that piece of equipment. So we're making long run times, and we're saving the longevity of the piece of equipment. So that's the exciting stuff that we're busting into as a more of a service type controls contractor. Question?
It's actually a tag on to what you just said, Russ. You use the term optimize. And that's different than preventive maintenance. Preventive says I'm going to keep the belt on the pulley and I'm going to keep the oil in the bearing and things like that. But optimize says what could we do differently or better than the original design. And I think there's a huge opportunity there. I'm completely biased from commissioning and retro commissioning experience that there are legacy systems that nobody's looked at for 5 years, 10 years, 20 years. So what do you guys think? But the optimization requires somebody to go into and understand what's going on now, how that could become something better and different. So what do you think about that opportunity?
Sure.
Yeah, that's a very good point, right? You know, when you're looking at bringing a building up to its full potential, there's kind of two pieces. One is how do you get it back to the level it was originally designed or conceived at, which is, you know, as we've been talking, can be quite a challenge sometimes. There's a lot of things to deal with there, but there's no reason to stop there. There's a lot of optimization that can be done, and it can be an overused word, but using the systems knowledge and the new technologies and things like that, new approaches, capture changes in space usage. Maybe they don't need it to be as cold or as ventilated or something as it was originally conceived. Well, there's no reason to do that. Let's turn it off, set it back, slow it down, something. There's no reason to stop at the building's original level. And it's, sometimes people are content to have their utility bills held at a certain level, which is good. Hey, I'm at a good level. I'm holding it here. I pay for my preventative maintenance. I hold it here. I'm good. But there's no reason to stop there. There's lots of ways to push that further and get some additional savings.
One thing I want to touch on, because you're only as good as, with these levers that, Greg was talking about, right? That you're saying that, you've got controls to pull levers, but you're only as good as the building itself. And what I mean by that is that if you're not looking at the building envelope, This harnessing thing does not make any sense. I mean, if you try to simulate some of the buildings, LEED certified buildings we have here, they leak like sieves. We have major infiltration issues in some cases in a lot of different buildings. So if you're not looking at the envelope, and now ASHRAE is actually by mandate on new building construction, and anytime that you touch the building envelope by mandate now with code, you actually have to look at an air barrier continuity, which frankly is not very sophisticated. It's just sealing up roof wall transitions, shafts, making sure that you have weather stripping. I mean, you would think that's not that big of a deal, right? It's elementary. But I've seen 10% across the board, 10% savings just sealing up the air barrier. Let's start there. I mean, we can talk about all the sexy stuff about sophisticated controls and wireless sensory networks, but if we don't have an envelope that actually is performed based on design, I mean, we've got all these Revit tools now that we can create these buildings, but then we have a contractor that walked in there and walked away and did seal roof wall transitions. So where's a good major case for that? Well, if you've got any cluster flies that are happening on windows, that could be a good indication you've got an air barrier issue. If you see cobwebs, those are air paths, right? So there's some things there. I mean, I see some representatives from Van Andel Institute. I mean, for the lack of, I spent as a as a worldwide executive for Kellogg with what we did in 3 different countries, and they need it for hygienic needs. Van Andel, healthcare, they need it for hygienic needs. That I would say let's start looking at the whole building within a building science approach. And there's some really quick ways you can do it. You can do you can do blower door tests and stuff like that. There's also, we call it the Billy Graham. He just passed away, so I'm going to give him. But we always called it the Billy Graham. Seeing is believing. It's a smoke pencil test. And that was not my term. I didn't create that. That was something from another company in Canada. But if you haven't done an air barrier study, I would look at that in any building, really. I mean, that should be part of commissioning right now, but it's not.
All right, we're coming down to a landing here with our time together. Is there one more burning question that you're going, doggone it, I wish they would have talked about this? All right, we got it.
What's a goal for a central computer-based controls or web-based controls?
Web. That's.
And I would agree, web-based controls. Because here.
Well, there's a few things. Number one, mobility. Being able to arm that tool in the hand of somebody that your facility manager gets an alarm at, hopefully not 2 a.m., but 10 o'clock at night, he'll be able to actually then make the change needed within, say, whatever it is that, whatever point's alarmed, to be able to figure that out. Mobility is a big one. The second thing is that when you have we're finding more protection security, and I'm going to go off into this space because it's my technology piece, but we're having more security with more cloud-based products than we are behind the client's firewall products. So security is, and this is things that you all have to be thinking about if you own your buildings and own operations, right? I mean, I don't want to say the hands, but there were a lot of people in Grand Rapids that got affected by WannaCry. Everybody know what that virus was? It took down healthcare systems here. This is the time that we live in. And if your facility, which is being managed by firmware and software, is not being protected, you got a problem. And if you think that it's on your side of the firewall, you even got a bigger problem. So it's actually really good to start looking at what my risk assessment is of those things as well. So I think cloud-based tools, especially on Amazon, I mean, there's a lot of different cloud-based tools that things are on. I forget what Trane, where you guys are on Amazon, aren't you? You do AWS. But the cool thing about that is when they do updates, they don't have to port in to your side and all that rigmarole. They just maintain it up in the cloud, and it just all of a sudden makes sense to run. And the encryption, I mean, we've got blockchain coming, and there's some pretty cool stuff that's happening that's going to make it even more secure. So if it's behind your firewall, I would say, so mobility, security, anything else?
Actually, one more to add to that, Rob, and that is just the fact that you have a physical server, and if it fails or if your building burns down or something like that, all your data's lost. It's gone forever. one more thing to touch base on that really pings my memory, Rob, is I was reading, you obviously heard 2 years ago, I believe it was, Target had that massive data breach. I was talking to a controls expert who was saying, do you know how the hackers got into Target's like POS system? Well, how they got in was through the HVAC system. There was unprotected areas in their network.
It wasn't Trane.
There was unprotected systems, and they got in through there and worked their way all the way into the credit card systems and stole all the data. So that's another thing is you're like you said, Rob, you're really opening yourself up to a lot of opportunities for security breaches, but also you have a physical server, and if it dies, you lose all of your data as well. So there's a number of reasons.
Thank you, everybody. I will turn it back over to you, and if you have any closing.
Thank you so much. Thank you, panelists, for donating your time to be here as experts. They all are representatives of companies who are part of the 2030 district. We really love to support our 2030 district members. Actually, Founders itself also is in Bad Elder Buildings as well as 2030. I would say thank you to David and Reese, but they're not here right now. But so we have a gift for you guys as a small token of our appreciation for you coming out. Founders beer. Hope you guys will enjoy. As Mike said, Battle of the Buildings. Go ahead, guys. Battle of the Buildings is going on right now. Founders is participating. I love to see what the Holland schools do in Battle. Their numbers are fantastic. So Battle of the Buildings is free for those to participate. And at the end, if it's free to participate and you're getting energy savings back, really it's a net savings for you in the long run anyway. And at the end, we have a celebration of building-to-building conversations. No vendors. Vendors can be there, but the keynote speakers and the peer-to-peer conversations are between the building owners themselves. And so again, if you're a finalist in the Battle of Buildings, it's free to come in. Do you see a trend here? And some of our companies that we have here are also contractors with people who participate in the Battle of the Buildings. So again, it's open until the end of March. Join. You have nothing to lose, literally. And the 2030 district itself has expanded its boundaries from the downtown district to support all of the city itself. So if you really want to be a part of all the great things that Grand Rapids is doing, join up now because we're going places and we want you to come with us. So thank you so much. And thank you for being here. And stay again for the next time.